Hello friends, today I'm going to solve LeetCode problem number 131, palindrome partitioning. So in this problem we are given a string S and we need to partition this string such that every substring is partitioned into a palindrome, and we are going to return all the palindrome partitioning of S. So what's a palindrome? It's a string that reads same, forward and backward. So let's see an example here. So if this is a string, then it is a palindrome because read forward it's ABA, and if we read it backward it's still ABA, right? So this is a palindrome. Also, a single string, a string with only single character is also a palindrome. So now that we know what's a palindrome is, let's see how we could find the substrings such that they are all palindrome, and we need to find every substring in the partition. So now here in this example, what are we going to do is we are going to use backtracking algorithm. So we will be using backtracking algorithm starting from the first index and then moving on to the next index. So the first index itself is a single character, right? So this is our starting position and the end position as well. So what we do is the first index is this single character, and we know single character is always a palindrome. So what we do is we have an empty array so far, and we also have like a result array. So this is our result array, and this is an array of current this is our current list of palindrome. So what we do is, since this single character is a palindrome, we push that character to our current list. And then now what do we have is we have AAB. We still have this string, but now we move to the next index because we are partitioning the string, right? So since this character is this substring is a palindrome, we need to check now, is the remaining substring palindrome? So we start from the first character and we check that it's again a single string. So since it is a palindrome, we push it to our current array. So we have A, we have another string A. Now this is our current array so far, and now we move to the next index, which is P, and this becomes our start and the end index. And since P is also a single character, so what we have is now in our current array is AAB, and then our string is AAB. And now since our pointer has moved to the beyond the end of the string, so that is when we know that we have found the substring for we have found all the palindromes for this substring, all the partitions of palindrome. So we push these to our result array. So we push these to our result array so far. So we have A comma B in our result array. Alright, so this is what we have now. We backtrack from this position. So since we were at this position, this was both our start and end index. Now we try to move the end index, but we know moving the end index to the next pointer would again mean that it's beyond the string. So we just keep on backtracking again, and we knew here that the start and end was the same point. Now we move the end pointer to the next index. Now since start is this, end is this, we will evaluate if AB is a palindrome in itself or not. And since we know that AB is not a palindrome, so we backtrack to our original string, which is at index 0, both the start and end index. So now our end index moves back to the next index, which is at index 1, and the substring that we are evaluating is now AA. And since AA is a palindrome, so what we get in our new list, because now we have backtracked, and while we are backtracking we are popping up, we are removing the elements from this list. So we have the empty element list, and in the empty list, since AA is a palindrome, so we push AA into our list, and then our string is AAB. And so far it was at index 1. Right now we look at index 2. So our substring is this, and is this a palindrome? This whole string is not a palindrome, right? This was our start index, this was our end index, and since this is not a palindrome, so what we do is our new start becomes the end. So since we already have AA, now this becomes our start. So since this is a start, and this will also be the end itself, starting from 0 index, so since it is only one character, so we push B to this array, and what we get is AAB. So we push this to our result array, and then finally we backtrack, and well, basically this will be our final answer. So now that we know how to the logic, the approach behind the solution, let's start coding. So let n equals to the length of the string, and then let us create our DP. So we are going to use dynamic programming approach, so that the space complexity, the time complexity is minimized, given that we are compromising over the space. So why are we using DP? Let me just tell you, give you a short example. Suppose that we have an array, a string like this, and we know that this is a palindrome because we have evaluated this palindrome. Because how do we proceed? We proceed with start index this one and end index as this value. Next our start and end index is this value. Next our start and end is this, then we move on to this, and then finally our start and end is both these, right? And then while we backtrack, our end keeps on increasing, right? So this is our start, now this becomes our end. Since previously its start and end were the same position at same index, now end is increased by 1, and then we evaluate this value, and then we backtrack again, and for this start position it has the end value at this position, but now our end value is increased by 1, and then again in the next iteration it's increased by 1 more. So similarly in this case also, our start and end, basically if you look at, just look generally, start and end is the same, and the next step, next iteration, end is increased by 1, in the next step again end is increased by 1, and then finally end is increased by 1 again. Now since we have already evaluated this string starting from the start and ending at this end position, we will know that this is a palindrome. So we will store the true value for this start and end index. And then next, while we will be evaluating the palindrome with this start index and this end index, we know that this value is a palindrome, and all we need to check is these two character equal. If these two characters are equal and this value is a palindrome, then we know that this whole substring is a palindrome in itself, right? So that is why we are using that the dynamic programming. Now let us define our DFS function. So we'll need our start index, and we will need the list to store our current partitions. And we are going to check our base case. If the value of start is equals to n, which means that we have reached the very end of the string, that is when we will push our result. So we are just pushing the copy of our result, and then what we do is we iterate for the end values. And is the start, because we know the start and the end initially is the same point, and later on we keep on increasing the value of end should be less than n. So we keep iterating over this end value as well. And we are gonna check if the start and end substring is a palindrome. So for that, what are we going to do? We check is the start character and end character the same, and also start. So what we checked is start and end character should be the same, and this substring should be a palindrome, right? So the substring between dp, so start plus 1 and end minus 1 should be a palindrome, right? This is start and this index is start plus 1, and since this is end and this index is end minus 1, that should be a palindrome. And what if in the case where we have not yet evaluated any of such characters? For example, if we have only these characters, and this is a start and this is end, so start plus 1 would be the end value and end minus 1 would be the start. At that point, we actually do not have the dp have found the value, have actually evaluated if this is a palindrome string or not. So, and also in the case where we only have 3 characters, we know that these 3 characters would definitely be palindrome, right? So in those 2 cases, we are going to check if or start. So the difference between start and end index, it should be less than equals to 2, if either of these 2 conditions are valid and this is valid, that is when it's a palindrome, and we are going to push it to our current list, push our substring, and we are going to perform our DFS function call. So the next start would be our next end value with the cursor, and we pop the values from our current list before we move on to the next iteration. And then finally we are going to call our DFS function from here and then return our result. Let's try to run our code. Cool, let's submit it now. Awesome.